Hello everyone, welcome to my YouTube channel. Today I'm going to discuss paper 41, October-November 2023. This is a theory paper. Let's start from question number 1. In question number 1, a list of gases is shown. So these are some gases and we have to answer in the terms of these gases, and each gas can be used once, more than once, or not at all. Give the name of the gas that causes acid rain. There are two gases which are responsible for acid rain: sulfur dioxide and nitrogen dioxide. So just check the list whether, okay, sulfur dioxide is there. So sulfur dioxide is responsible for the acid rain. Nitrogen dioxide is also uh, it contributes to the acid rain, but nitrogen dioxide is not in the list. Forms an alkaline solution when dissolved in water. The ammonia is the only alkaline gas in 0620 syllabus. So the answer is ammonia. Inert. Inert gases are group 8 gases, noble gases. So just look at the group 8, helium, neon, argon, krypton, xenon, radon. So these are the gases of group 8A. So xenon is the gas which is inert, is produced of by the photosynthesis or the product of the photosynthesis. Photosynthesis is the reaction of carbon dioxide and water to get glucose plus oxygen. So there are 6 carbon, then 12 hydrogen. You can put 6 here, 6 here. So two products are there, glucose and oxygen. So these are the two reactants. So oxygen is the product. Can form a polymer. Polymerization is the property of alkene. So all the hydrocarbons which contain double covalent bond, or in the name, they have the ending code or suffix "ene." They are responsible for the polymerization. Just check the name. Ethene, as the ending code is "ene." So this is alkene, contains double covalent bond between carbon to carbon. So that is responsible for polymerization. Is produced in the test of nitrate ions. So nitrate ions, they can be tested by adding aqueous sodium hydroxide, and if we react the nitrate ion with the aqueous sodium hydroxide, then we can warm the mixture. We will get a ammonia gas, which turns moist red litmus paper blue. So during the test for the nitrate ion, ammonia gas is produced. So ammonia is the answer. So this was the first question. Not much difficult question, but a student will have to know the points of the syllabus. Then he or she will be able to get good grade. There is another question, question number 2. Boron and aluminium are the group 3 elements. Boron has only 2 naturally occurring isotopes, P10, P11. So complete the table 2.1, number of protons. So we can pick the proton number from the periodic table. 5 is the proton number. So number of protons, there must be 5 protons and 5 electron, because this is regarding atom. And then number of neutrons, in P11, 11 minus 5, which is 6. The next question is that determine the relative atomic mass of the boron of one decimal place is 10.8. To determine the relative abundance of P10 present in the boron, give your answer as a percentage. The formula is that AR is mass into abundance plus mass into abundance over total abundance. So the percentage mean 100. So if we have a mass into abundance plus mass times abundance over total abundance is 100. So the AR is given 10.8 is the AR. The mass numbers are there, 10 and 11, but we don't have idea about the abundance. Suppose that the abundance of B10 is X, so 10 is the mass, X is the abundance. Plus, as the percentage is 100, so the mass of the second isotope, it must be 100 minus X times 11, and the overall percentage is 100. So if we multiply 10.8 into 100, so this is 1080 is equal to 10x, uh, and then 11 times 100 plus 1100 minus 11x. So 1080 is minus x plus 1100, or we can say x is 1100 minus 1080. So this is 20%. So the answer is 20%. Then use the relative atomic mass of boron to calculate the number of atoms in this. So the number of particles, the number of particles or number of atoms can be calculating by multiplying the moles with the Avogadro's constant. So first of all, calculate the moles in boron. 0.540 is the mass, and 10.8 is the AR. So there are 0.05 moles. So if we multiply the moles with Avogadro's constant, we will get number of atoms, so the number of the particles. So 0.05 are the moles. 6.02 times 10 raised to power 23, the Avogadro's constant, and if we multiply these two numbers, we will get 3.01 times 10 raised to power 22. So these are the number of atoms present in 0.54 grams of boron. Okay, the next one, this question is regarding the extraction of aluminium, and the name, the ore of aluminium. Cryolite is the name of the ore, which is used to extract, uh, bauxite is the ore. Cryolite is not the ore, bauxite is the ore, which is used to extract aluminium in chemical industry. So the electrolyte contains aluminium oxide and one other substance. So name the other substance. That this is the cryolite, that bauxite plus cryolite, they are taken. So the function of the cryolite, or the purpose of the cryolite, is that it helps to reduce the melting point of aluminium oxide, helps to reduce melting point of aluminium oxide, or melting point of mixture, because now this is impure aluminium oxide. When we add cryolite in bauxite or aluminium oxide, and impurity causes reduction in melting point, so that's where the melting point will reduce. Or it also helps to improve conductivity, because it produces more number of ions, and when there are more number of free ions, that improves the conductivity. Write the ionic half equation for the reaction at cathode. Cathode is a negative electrode in which aluminium ions are reduced. So Al3 positive plus 3 electron Al. Because aluminium oxide that ionizes to give Al3 positive and O2 negative cations, they will start moving towards cathode, and anions towards anode. Cations are reduced at cathode to get aluminium metal, and anions are oxidized at anode to get oxygen metal. So explain why the anode need frequent replacement. Now, anode is a positive electrode, and on anode we are getting oxygen gas, and the oxygen gas can react with the anode, carbon anode, as the working temperature of uh, as working temperature of cell is 940 to 980. or 980 to 100 degrees Celsius. So oxygen reacts with carbon electrodes called carbon anode to form carbon dioxide, and carbon anode evaporates in the form of carbon dioxide. So that's why uh, the anodes need a frequent replacement. State two physical properties of aluminium that make it suitable to use in overhead electrical cables. And the first thing must be the good conductivity, mean the aluminium is a good conductor of electricity. And the second thing is that it has a low density. So these are the two features of aluminium which make the aluminium to use in overhead electrical cables. Explain the apparent unreactivity of aluminium, as aluminium is a little bit above in the reactivity series. So aluminium is a reactive metal and it reacts with the oxygen to form oxide coating, and that oxide coating makes it unreactive. So aluminium is a reactive metal, uh, reacts with oxygen to form aluminium oxide, which makes it unreactive. Then aluminium reacts with the fluorine. Uh, this is aluminium. Fluorine is the noble legend, which is diatomic. So this is AlF3, and the balancing coefficients, there are three fluorine. So if we put 2 here, it becomes 6. So it is 6, now 2 aluminium, 2 aluminium. So this is the balanced chemical equation. The next question is that electronic configuration of aluminium ion and fluoride ion. Aluminium 13 proton number, that is in group 3, so that's where the charge must be 3 positive. Fluorine in group 7, so the charge is 2 negative. Aluminium loses 3 electron, 13 is the proton number. When it loses 3 electron, then 10 electrons are there now. So 2 has already shown, so just draw the 8 more. 4, 5, 6, 7, 8, 10 electrons are there. Fluorine, 9 is the proton number, 2 are already shown. The electronic configuration of fluorine is 2, 7. So 2 electrons are already there. 3, 4, 5, 6, 7, 8, 9. So 9 is the proton number. Fluorine gained 1 electron, so that's why the charge of the fluorine must be 1 negative. Sorry, fluorine is in the group 7, so it will get the 1 negative charge. So this is aluminium fluoride. Then order of reactivity can be determined by displacement reaction. As we can see that lead, manganese, silver, zinc, they are reacted with the different aqueous solutions. I mean, if we have our 4 test tubes and which contains the different solutions, and then we add the lead, manganese, silver, and zinc, and we check whether the reaction will take place or not. So if we look at the reactivity series, we know that the reactivity of zinc, silver, and lead, that zinc is the most reactive, and then there is lead, and then there is silver. Okay, but we don't know the reactivity of manganese as well. So if we look at the manganese, so manganese, uh, when it reacts with the lead to nitrate, the displacement occurs, mean the manganese is more reactive than lead. Manganese is more reactive than lead. So here is a manganese, because zinc is more reactive than lead. Zinc is more reactive than manganese. Zinc is more reactive than silver. So zinc is the more reactive metal. It must be at the top. Silver is the least reactive, must be at the bottom. And then This is the reaction, whether the reaction take place or not. Then number one, zinc is the most reactive. Number two, then there is a manganese, then there is a lead, and at the end, silver. So just why the metal nitrates and not the metal sulfates of these four? Metal sulfates are generally insoluble, and the metal nitrates are soluble. So if we use the insoluble salt, definitely the displacement reaction is not possible. So metal salts, which are sulfate, if we use the lead sulfate, so lead sulfate is insoluble, or you can say the metal sulfates are insoluble, or metal nitrates are soluble. So that's why we're using the nitrates instead of sulfates. Symbol equation for the reaction between zinc and silver nitrate. This is zinc, and the silver nitrate is AgNO3. Zinc has two charges, so zinc nitrate must be like this, and then silver is less reactive than zinc, so zinc displaces silver. So there are two nitrates. If we put two here, two silver, I can put two here. This is the balanced chemical equation. Then the next question is the reactivity of the group 7 elements can be investigated experimentally. A student bubbles chlorine gas into the test tube containing aqueous potassium bromide. So this is potassium bromide, and we are bubbling chlorine gas. Describe the color change seen. The color of aqueous potassium bromide is colorless. Then this is colorless. And the reaction between chlorine and potassium bromide is to give potassium chloride plus Br2. So this is orange solution. Br2 solution is orange, to colorless to orange. Now complete the ionic equation. So this in KBr, the Br is in the form of negative. So this is negative. So just put the Cl2 here. In KCl, the Cl is negative, and then there is a Br2, so you can balance this equation. There are two chlorines, so you can put two here, two bromine, you can put two here. So this is the balanced ionic equation. Chlorine gas is bubbled through aqueous, and we are getting the aqueous solution of chloride ion and the aqueous solution of bromine. Then the reactivity trend seen in the chlorine bromine iodine applies to all the elements of group 7. Use the periodic table. So you have to use the periodic table to identify the group 7 element, which cannot displace any other group 7 element. So just look at the periodic table. Periodic table is there in the question paper, and if we look at the periodic table, the group 7 element is astatine, and then this is another element in the periodic table. This is the latest version of the periodic table. So TS, the element TS, you can copy the name as well as the symbol of the element from this periodic table. Okay, so let me write down the name of this element or the symbol. So TS is the element, or tennessine is the element which is least reactive. Now, there is another question. Hydrogen peroxide decomposes to give water and oxygen. So state the test for oxygen gas. Oxygen gas relights glowing splint. So we can say the test is that if we put a glowing splint, and observation is relights. So oxygen relights glowing splint. Then there's a question that the rate of the formation of hydrogen gas when manganese fluoride added to aqueous hydrogen peroxide. So the volume of the oxygen gas, here we are getting the oxygen gas. State how the graph in figure 4.1 shows that the rate of the reaction in time T2, this is T2, is lower than that of in time T. So if you look at the curve, at the curve gets less steeper. So that's why we can say the at time t, at time t2, there is a lower gradient because the curve gets less steep. Explain using Collision theory why the rate of the reaction at time T2 is lower than that of T1. As our reactant is hydrogen peroxide, so when the time passes, the concentration of hydrogen peroxide particles decreases. So if there are more particles, more frequent collisions, and if there are less particles, so definitely the less frequent collisions or the frequency of the collision will start decreasing. So when at the start, the concentration of hydrogen peroxide is maximum. So when the time passes, the concentration of H2O2 particles that decreases. And then frequency of collisions between these particles will also decrease because now we have less number of particles. So frequency of collisions between particles that will also decrease. So this is the explanation on the basis of collision theory. Then uh, if this experiment is repeated using aqueous hydrogen peroxide at a higher temperature, all other conditions remain the same. So sketch the graph obtained. If the temperature is higher, rate of reaction increases, but we will get the same amount of oxygen or the same volume. So the curve it should be a little bit more steeper, but it must finish at the same level. You will get the same volume at low and at high temperature. Curve should be more steeper and levels off at the same level. Now, the manganese oxide is added to 20 centimeter cube of aqueous hydrogen peroxide. The total volume of the oxygen is 72. So this is 72 centimeter cube of oxygen is formed. So calculate the concentration of aqueous hydrogen peroxide in grams per dm cube. Okay, now the concentration in grams per dm cube can be calculated if we have the concentration in moles per dm cube and multiplied by mr. So the concentration of moles per dm cube, we can get the concentration in moles per dm cube. Its formula is moles times 1000 by volume in cm cube. And if we have the mr and the concentration of hydrogen peroxide, then we can calculate the concentration of hydrogen peroxide in grams per dm cube. But to calculate the concentration of hydrogen peroxide in moles per dm cube, we must have the moles of hydrogen peroxide, but we don't have the moles of hydrogen peroxide, only the volume is there, 20. So we can put 20 here, but we don't have the moles. To calculate the moles of hydrogen peroxide, first of all, calculate the moles of oxygen, then do the stoichiometry, and then you can follow this method to get the answer. So calculate the number of moles of oxygen. So there are 72 because the room temperature and pressure. So at 72 divided by 24,000, you will get the number of moles, which are 0.003. So 0.003 moles of oxygen are there. If we look at the stoichiometry of the equation or the ratio of oxygen and hydrogen peroxide, so this is 1:2. So the moles of hydrogen peroxide, these are the moles of oxygen. So the moles of hydrogen peroxide, they are 2 times. So 0.003 times 2, which is 0.006. Now, calculate the concentration of aqueous hydrogen peroxide in moles per dm cube. So the concentration of hydrogen peroxide is H2O2, is moles 0.006 times 1000 by 20, because 20 centimeter cube is the volume of hydrogen peroxide given in the question. So it is 0.3. So 0.30 moles of hydrogen peroxides are there, then the concentration of hydrogen peroxide uh, in grams per dm cube. Now the moles are 0.30 times the mr1 times 2 plus 16 times 2. So 0.30 times 34. 34 is the mr of hydrogen peroxide. So it will become 10.2 grams per dm cube. State the identity of one other metal oxide. Generally, the transition metals and their oxides, they can be used as a catalyst. So you can use the copper oxide or any transition metal oxide. Okay, the next part is regarding the reversible reaction. So this is a reversible reaction in which the methane combines with the steam to get carbon monoxide and hydrogen gas. Two features of an equilibrium. Equilibrium is the state of reversible reaction when the rate of the forward reaction exactly equals to the rate of reverse reaction, and the concentration of reactants in the products become constant. So these are the two features, as where the rate of forward reaction is equals to rate of reverse reaction, and the concentration of both reactants and products becomes constant. There is no change in the concentration of reactants in the product at equilibrium. State and explain the terms of equilibrium. What happens to the concentration of hydrogen when the pressure is increased? When the pressure is increased, uh, there are 2 moles on the left hand side and 4 moles on the right hand side. So when pressure is increased, the position of equilibrium shifts to left because it shifts from more moles to less moles. So if the position of equilibrium shifts to left, equilibrium shifts to left as the hydrogen is on the right hand side, so the concentration of hydrogen decreases. The temperature is increased. Whenever you have to look at the effect of temperature on the reversible reaction, just look at the enthalpy change. The enthalpy change is positive, so forward reaction is endothermic, and the reverse reaction is exothermic. So if the temperature is increased, the equilibrium shifts in that direction where it can minimize the effect of increased temperature. So in the forward direction, we can see that the temperature is used up. So that's why if we increase the temperature, what will happen? The equilibrium shifts to right. Equilibrium shifts to right as the forward reaction is. Forward reaction is endothermic. And concentration of hydrogen increases. A catalyst is used. The catalyst has no effect on the position of equilibrium, so there will be no change because catalysts do not affect the position of equilibrium. Catalyst increases the rate of both forward and reverse reaction, and it helps to establish the equilibrium in a shorter time. Now, the greenhouse gas found in the clean, dry air, carbon dioxide, is the greenhouse gas. Now, explain in the terms of thermal energy how greenhouse gases cause global warming. Actually, the greenhouse gases they absorb thermal energy from the earth. absorb thermal energy from Earth, and this thermal energy is absorbed by the Earth from the Sun. So this energy comes from the Sun. So Earth absorbs energy from the Sun, and if we increase the increasing amount of greenhouse gases, increases the global temperature, or it causes the global warming. Okay, the next question is regarding organic chemistry. I will solve this question in the next video.